Hi there, welcome back. Video 2 of the Telefunken Gavotte 55. And yeah, I've got some progress already. But as you'll see, this thing, progress on these projects can be quite slow, which doesn't sometimes show up on the YouTube videos. But let me show you something before we go into that. Look at that. Just look at that. I've cleaned a small portion of the chassis, this part here, and that part there. And this stuff is, or this thing is absolutely shiny. It's almost like this thing was made of stainless steel. It's cleaning up incredibly well. Absolutely no tarnishing on the metal itself. So I think we're going to have a really good result. I hope the function is as good as the looks when it's finished, but we shall see. I started as usual with the power supply section, starting with the mains input. The mains comes in, it goes through a fuse, goes through a switch, and I've got it to the point where if you take a multimeter and you put it across the two prongs of the mains cord, now if you remember the schematic, the cord goes in, it goes through a fuse. That's the fuse over there. That fuse was repaired as well, it was broken. It wasn't actually blown, but the end cap was loose, so I replaced it. If you take that continuity from one side, goes through the fuse, it goes through the transformer, the primary, it comes out of the transformer, it goes to the switch, the other side of the switch should come back here. So when you hit the switch, we get 90-something ohms, okay? And if I select one of the others, it's the same. If I switch it off, no, off is the wrong one. There's off, it goes off. Now, something as simple as that took me a good hour. And the reason is everything is tarnished. So the prongs there are tarnished, so you've got to clean them up, make sure that your contact is clear. The switch, or rather the fuse connections were bad. This thing's moving around. Fuse connections were bad, so I had to clean that as well. And the switch was incredibly corroded. It was giving me absolutely no connection. So two things would happen. I'd have to remove the switch and replace it, or try and open it up and clean it, or the alternative, which is what I did, was I just kept spraying contact cleaner and using it, activating it on and off, on and off, on and off, on and off. I can't tell you how long it went before this thing started making a reliable continuity. That resistance you're seeing there is some lead resistance and also the primary resistance of the mains transformer. Now, I've already set this to 240 volts because if you look at that, 94.6 ohms, if I turn it to 220, 85 ohms. If I turn it to 150, (52 ohms). So what we're getting here is we're seeing that the primary is tapped at various sections for different voltages, and obviously the one we want is the one that has the greater number of turns, which gives us 240 in. Something is moved again. There we go. That's about right. I've got to put some more contact cleaner on there. But it's about there, 90 or thereabouts. You see, I just have to touch this. And the tarnish on this, let's try and get a better connection here. The fuse. Everything is affecting this. Let me go to the switch again. It is still not absolutely functional. Actually, it seems to be here. These connectors, these prongs here, need to be cleared up a bit more. But yeah, you can see it's going to come down. The message I'm trying to get across here is to get this primary circuit working with a multimeter with low voltage to measure the continuity takes a heck of a long time, but you can get it done. And that saved me having to replace the switch. Now, when I put mains through here, because of the high voltage, all this continuity hassle will disappear. I'm sure of that. Let me just do this again. Yeah, everything needs another spraying of contact cleaner, because it's not absolutely. There's contact cleaner required here on the switch, on the contacts of the fuse, because these things get tarnished on the inside. You can see that it's all jumping all over the place, and it's all got to do with the contacts and the fact that we're using a low voltage to measure the continuity. So it doesn't mean that this thing wouldn't work, because the minute you put 220 volts or 240 volts on here, believe me, it'll work. It'll go straight across, and all these continuity issues would disappear. You will not see some of the contact resistances that we're getting on here. But this is the sort of thing that you can come short on because you don't know exactly what's going on there. So I've checked the primary circuit. I've replaced the fuse. I've started seeing how I can get the cleaning done, and it looks like it's going to be a fabulous result. And the next step is I want to work on the power supply. So first things first, it'll be the Selenium Rectifier, and there's our next challenge. The Selenium Rectifier receives 2 AC lines from the mains transformer, and then there's 2 outputs. One is the positive and one is the ground. Now, they're all in this thing, or the Selenium Rectifier is in this thing, and I want to replace it, but I want to keep the aesthetics exactly the same. I could just cut those wires there and put a bridge rectifier of sorts, but I want to incorporate it into this chassis, empty this out, and leave the thing looking exactly the same as it is now. And to do that, I have a few challenges. The first one is the fact, you can't really see that, it's the fact that this Selenium Rectifier is not the usual one. If you look over there, that thing has got 4 wires coming straight out of it. You can't really see it, but there are no solder tags on there. There are no tags at all. These wires come from the inside of this unit. So to remove it, I've got to desolder that ground blob, which is connected to the chassis. That's easy enough. But then I've got to remove the wires from where they are connected to, because I can't remove them from the Selenium Rectifier because they're going into the Selenium Rectifier. So to do that, I've followed the wires. If we look at these wires over here, they go into or through the chassis. 2 of these wires are the secondary output, AC, comes into the Selenium Rectifier. Those 2 wires go in a yellow sheath. It goes through the chassis. I don't know if you can see that. Goes through the chassis out into the top there. The other 2 are actually 2 red wires. So that'll be the output. They go also, or one of the red wires goes into the black sheath that comes out the top there. And these 2 wires come out here, the yellow ones. Those go to this connector here. It's soldered in there, and it goes back into there as 2 yellows, and these 2 are connected to a solder point over there that are the secondary output from the transformer. These 2 reds come out. One of them is from the Selenium Rectifier, the other one goes to the capacitor, and they go to the output transformer over there. Now, because I want to keep this thing as original as possible, I'm actually going to remove all these, pull the whole Selenium Rectifier out, and when I replace the Selenium Rectifier with a bridge rectifier inside that unit, I want the same wires coming out and following these paths. So it makes it a little bit more tiresome to do, but I have to do it. So I have to desolder those 2 wires there, pull that black sheath out, that'll come out the other side. I have to desolder, I have to move this shield, the sheath over here aside, because there's a solder connection inside there. or maybe I'll just desolder it from the underside and pull the whole thing out, and that whole thing will go out the other side so that I then have to put everything back. And the reason for that is I want to keep this thing as original looking as possible, using the same wires, the same color scheme, and the same lead dress that this radio has. I'm trying, not sure that I'm going to succeed, but I want to get to the end, and I want you to be able to look at this thing and see as little change as possible from the original state that it's in. Not sure what I'm going to do with these caps up here, but we'll see if we can work around that as well. So you see, something as simple as replacing a selenium rectifier is now a major task, because it's not a repair, it's a restoration. And it's not a normal restoration, it's a restoration that I don't want my friends at the radio museum to be embarrassed about. All right, I've got to get on with it. I'll come back a few hours later when I've done 5 minutes of work. Did I say 5 minutes of work? Well, it's been quite a bit more than that. But this is the result. The selenium rectifier is in place, and other than it being twisted a bit, you can't tell this thing's been moved. The connections here have all been done. The wiring has been routed again through the original track. And there it is, coming out there, all the way down. Those are the yellows. The two reds do the same. They come up here and they go to the connector on the output transformer. Now the output transformer has also seen quite a bit of change. I've replaced the two caps on there. I actually considered stuffing them, but honestly couldn't get it right. So what I did is I wrapped the new capacitors in heat shrink and wrote their values on there. They're obviously replacements. In fact, what I found is that at least one of those that was there was not original anyway. This one here is definitely not original. It's old, but it's not the same vintage. This guy was completely kaput. It was reading like 3 microfarads, I think it was. Looking in pretty bad shape. And this is that power resistor that is used to drop from the first B+, the second B+. It had obviously suffered quite a bit, and in fact is completely open. So I had to replace that as well. And after cleaning all the connections and making sure that everything is wired properly, that's what it looks like. Our transformer is done. But if you're observant, you'll see that quite a bit more than that is done. I got cleaning and I couldn't stop. Yeah, it's hard to believe. This whole thing has been cleaned up. The whole top of the chassis has been cleaned up. And the reason it got cleaned up so early is because it was cleaning up so well. I mean, this thing has come out beautifully. There isn't one spot of rust on this thing. Everything was just a little bit of dirt. And with a lot of isopropyl alcohol and a lot of cotton swabs, which actually my friend who sent me this radio from the museum sent me a whole box of them. A lot of them got used on this. And the difference can be seen over here. That section hasn't been done yet, so you can see the difference over here. Look at this. Beautiful. And something else has been done as well. I've restuffed that capacitor. That is 2 by 50 microfarads. I ripped its guts out and I replaced it with 2 new 47 microfarad 400 volt caps. So that's also connected in. And that comes out the bottom there to the same places that it was on before. I've used the same wires that were there, because this is another one where the wires come from the inside. There's no solder tags except the ground lug. So that's been done. And other than that, in here, very little has been done. A bit of cleaning was done there because that's where I needed to pass the those yellow wires through and the reds. So I clean it as I go along. But the result is, at the moment, I have the power supply completely done. The selenium rectifier has been replaced and the 2 filter caps have been replaced. And that one dropping resistor, which was open, has been replaced as well. And just to show you what an obsession is, it's when you can't stop cleaning. I took the front off. This thing was incredibly grubby at the back here. And I just started. And before I knew it, I was engrossed. It was 2 in the morning. And I cleaned most of it up. Now, there's still a bit more to do on the front here. I'm not sure that the dial lamp is working. It could be blown, but I'll find out. So most of the front is done. I need to replace that. There's actually a film, a sort of grease paper backing there. I'm going to redo that. That one's completely crummy. And then I can put the front back on. But at the moment, what I've got so far is power supply done and a heck of a lot of cleaning of the chassis. As I said, very gratifying. Now, when I say the power supply is done, yes, it's done, but I don't have a dropping resistor to compensate for the change in the secondary voltage. When you do replace a Selenium Rectifier with a silicon rectifier, bridge rectifier, you sometimes need to drop a few volts because the voltage drop across the diode bridge is about 1.4 volts, whereas on a Selenium Rectifier it's quite a lot more. But I've also decided to give it a try without worrying too much about that because I've selected the 240 volt input at the back, which on some radios I don't have. And I'm hoping that by selecting 240 volts and having, 230 going in, I may not even need to use a dropping resistor. But that I'll find out when I find out. What I'm going to do now is I'm actually going to prepare this for the first fire up. I hope that word doesn't stick with me. The first power on. And what I'm going to do for that is I'm going to... No. Hang on. I need to make sure the coupling caps are not leaking completely, so I'm going to take it a little bit slower and not rush it. I was getting myself wound up already. But yeah, this is where we've got so far. We've got the chassis cleaned up and I'm really pleased with the result. As I said, I hope it works as well as it looks. But yeah, we'll see. I'm going to give it a break for now and I'll come back very, very soon with this thing ready to do a first power up. So once again, thanks for watching. And if you enjoyed that, please click like, share, subscribe and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Links are at the end of the video. Thanks for watching. Bye for now and stay safe.